Hello, my name is Vianne Tilson. I worked for a number of years as an elementary classroom teacher, then as a school principal, and most recently as a superintendent of a medium-sized school district in Missouri. It is my passion to get K-8 students excited and eager to do more science because science can change life outcomes for our students. However, in too many of our elementary schools, students only read about science with little opportunity for hands-on exploration. You may have heard some of the buzz around Sangari, and it's true. Sangari takes science to another level. Sangari is an organization committed to being partners with you in making science really come alive for your teachers and students. Over the past couple of years, Sangari interviewed hundreds of educators nationwide, asking one fundamental question. If you could have the world's best science program in your classroom, what would that look like? They told us very loud and clear that for a science program to be world-class, it must have three main components. First, high quality, fully colored curriculum aligned to the conceptual framework for new science education standards as well as your state standards. Second, easy-to-use materials and supplies with help in managing them to save time for teachers. And third, ongoing and meaningful training, not just once during the summer, but training provided by actual science coaches right in their classrooms for several days over the course of the year. We know that most teachers want to get better at teaching science, structuring lessons around interesting questions, and then guiding students to discover the answers. But the question is, how? Well, we listened and we came up with the answer. We incorporated these three main components into the Sangari Active Science program, and then we went even further. Sangari's unique technological components are also world-class. We provide a computing tablet for every classroom teacher to access their science program. Teachers access the Sangari Teacher Portal for online assessments, benchmarks, a classroom dashboard, grade books, professional development videos, and connections to other classroom teachers anywhere in the world. In addition, since the Sangari Teacher Portal provides all the lessons in digital format, teachers always have access to the freshest content.
Prove it. Let me see. Let me zoom in.
From this?
From a potato?
Yeah.
Cool.
Right there.
Nice.
We got it.
You got it? Can I see?
Yeah. Because this.
Wow. So what did you learn from this?
That, well, you do need the yellow sponge.
What does it do?
It makes a part for both of these to hold on to. And it acts as another battery.
Because this is connected to the metal part, and the dragons are connected.
Powering that.
Well, inside the battery, there's this bar and there's this bar, and one of them is the positive and one of them is the negative. So these act as a battery, but they need a place to go into, and that's why you use the potatoes.
Welcome to Machines in Motion Lesson 5. How do wheels help put objects in motion?
In the last 3 lessons, you and your students explored levers. In this lesson, you'll move on to a different type of simple machine, the wheel.
Now, when your students think of wheels, they probably think car, truck, train, but the earliest known use of the wheel was actually horizontal, the potter's wheel.
Harry Potter?
No, like 5,500 years before Harry Potter. Anyway, wheels were also probably used by fishermen to move their boats on land. They did this by rolling the boat on top of cylindrical tree trunks, which these dowels here represent. But don't tell your students that.
No, in this lesson's activity, your students will try and figure that out for themselves.
Okay, so let's say that this jar here is an early boat. And what I've built here out of these green rods that we used in lesson 2 to build those levers, just reconfigured a little bit. I've got a lot more washers that I'm using as spacers here. So this ends up being kind of a raft.
And you'll also use the force indicators that your students built in lesson 4. And you'll attach it just like that, and tighten the washer. And you can use them to measure the force that it takes to move your boat across a surface.
Of course, those black lines on the force indicator will tell your students how much force they're using to get the boat from A to B. Now, this is kind of an unstructured activity, so let the teams play around with different materials and experiment and see what works best in terms of getting from here to there with the least amount of force.
See if any of the teams used the cylinders to roll the boat like those early fishermen. If not, give them hints to help guide them to that conclusion.
So now we're going to toss it over to Victor, who's going to tell us all about his hatred of friction and his love of the wheel.
Have fun.
I've heard myself say it 1,000 times. I hate friction. Friction is the force, a push or pull, that prevents motion or slows it down when two surfaces are in contact. I don't like drag or air friction against my car, slowing it down. So I try to choose a car aerodynamically designed to reduce that friction. I don't like friction in my car parts, so I use lubricant and motor oil. Friction wears my brakes down, makes my pencil less sharp, and chaps the skin around my nose when I blow it too much. But did you know friction can be good? Your students will find that friction affects how well they can get their boat to move. Yeah, it's actually friction that allows us to run or for wheels to rotate and move. It reminds me of the last time I was stuck in snow. My wheels rotated, but they spun in place. If there were proper friction between my wheels and the ground, actual traction, my wheels would have tried to rotate, gripped the ground due to friction, and propelled the car forward. Friction allows wheels to take us places. Encourage your students to discuss other situations where friction is helpful. Think of it like this. In cars today, what do we always find with wheels? Axles. You see, a wheel is a simple machine because it provides a mechanical advantage to an axle. In this case, a wheel and axle are a type of second-class lever that can rotate 360 degrees. The road applies the frictional force or effort force to the wheel. The center of the axle is the fulcrum point, and the load force is what the axle experiences. So you see, the wheel and the axle use friction to allow the motion or movement of an object. But they also have one more advantage. Which is easier, dragging an object across the floor or pulling the same object on a small car with axles and wheels? The latter is easier. So the wheel and axle also reduce friction compared to the alternative, dragging the object. By placing an object on an axle and wheels, the amount of friction impeding motion is reduced. Let's review. The wheel and axle, number one, use friction to move, and also, number two, reduce friction from dragging. Now, a simple machine that uses friction to move and reduces friction from dragging is quite convenient. I'd say the wheel is a pretty good invention.
I know times are tough financially for most school districts. However, giving the importance of having science in our curriculum to the future of our kids, this opportunity is too good to miss. You can contact us by clicking on the link below. Take care, and thanks for listening.